Hi, this is Alex Galt, and I'm looking at 2.6, which is about some derivative rules. My goal for you is to be able to calculate derivatives of some familiar functions. So first of all, let's look at the familiar function f of x equals 4, or y equals 4. Imagine that graph for a second. Think about what it looks like. And if the derivative means a function that tells you the slope at any given point, what should the derivative be for f of x equals 4? What do you think the derivative is for that function? And now here's a picture of y equals 4. I hope that you said, well, the derivative should be 0 because this is a horizontal line. I know the slope of the horizontal line. I don't care what the x-coordinate is. If the line is always horizontal, the slope is always 0. So this is our first derivative rule. The derivative rule says the derivative of a constant is 0. So if your function is a constant, and here I'm using k to just mean any constant, then the derivative is 0. An example, this is kind of a tricky example. Sometimes I see people say, well, if f of x equals pi to the third, what is the derivative of that? And sometimes people say, well, I learned the power rule, so maybe it's 3 times pi squared. And the answer is no, because pi is a constant, the derivative would be 0. The next rule, I feel like you should have a little dance party about this. This is the sum or difference rule. If your function is the sum of two other functions or the difference of two other functions, then the derivative, you just take the derivative of each function separately and add those together. It gives you, the reason I think you should have a dance party is because this behaves exactly the way you want it to. You want the derivatives to be logical, and in this case, they are exactly the way you want them to be. We're going to do a quick proof of this. Don't groan, this is not a bad proof. So with a proof, you start with the given. So the given is that your function is the sum, and I'm not going to do difference, I'm just going to do sum. The difference rule is very similar. So our given is that the function is the sum of two other functions. And so then we want to figure out what's the derivative of the function. And for that, we have to go back to the definition of the derivative. So the definition of the derivative is going to be that limit as h goes to 0 business. So that means that we would have to do u of x plus h plus v of x plus h, and we plug in x plus h in, minus, oh, I didn't give myself enough space, u of x plus v of x all over h. And the reason for that is the definition of a derivative. Definition of derivative says f prime is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. I'm using the definition of a derivative here. Now, I don't have anything that's recognizable yet, so I'm going to do a little more playing with it. I'm going to distribute that negative sign, so I have the limit as h goes to 0. For that is the distributive property. Now I'm going to rewrite things in a slightly different order. So I'm going to gather the u's together and write those down. So u of x plus h minus u of x all over h. And then plus v of x plus h minus v of x all over h. So this was a common denominator of h, and I just split it into two separate fractions, and I rearranged terms a little bit. So I put my u's together and I put my v's together, and that's what I just did. So kind of the rules there were kind of rules of algebra. I got a little bit messier. But what I hope you can see now is that this, along with that limit as h goes to 0, is u prime. That's the definition of u prime. And this, along with the limit as h goes to 0, is the definition of v prime, the definition of the derivative. So we went from this statement, which was our given, to knowing that the derivative is equal to the derivative of the sum of the derivatives. Again, here we're using definition of a derivative backwards. So the next rule is the constant multiple rule. If my function is a constant times a function, then its derivative is going to be the constant times the derivative. Again, this is another easy proof. We go with start with our given. And then if we want to take the derivative, we go back to the definition of derivatives. So that would be the limit as h goes to 0 of k times x, k times u of x plus h minus k times u of x over h. I can factor a k out of the numerator, so I have that as the limit as h goes to 0 of k times u of x plus h minus u of x over h. And this part is u prime. So if I write that down, then, well, along with the limit, that part is u prime. So I just have k times the derivative of u. I was a little less careful with this one, but again, we used definition of derivative, we used algebra rules, and then we used definition of derivative again. So we have some examples. The first example, h of x equals 2x to the third. So if I want to take the derivative of that, I can use the constant multiple rule. So that would be 2 times, and now I can use the power rule. So the power rule says 3 times x, 3 times x squared. So another way of writing that would be the derivative is equal to 6 times x squared. That's the constant multiple rule. It says, I know how to do the derivative of x cubed. I know how to do this derivative, but I have a constant times that derivative, so I then can just multiply them together. Next example, this looks like a quadratic. We can now take the derivative of a quadratic. Just say, well, f prime would be, here's a difference. We also have a constant multiple here, so this, I would bring the exponent down, so it would be 14 times x to the 1 power minus, the derivative of 9, well, 9 is just a constant, so the derivative would be 0. So another way of writing that would be f prime of x equals 14x. The last example, again, remember when you see things written weird, before you even start taking derivatives, rewrite it so you can use your power rule. So this is 5x to the negative 2 plus 4x. There's a couple of different constant multiples here, so we're going to take derivatives. Power rule and constant multiple rule, so I get negative 10 x to the negative third because you subtract 1 from the exponent, plus 4, the exponent is 1, times x to the 0. And if I rewrite that just a little bit to make it prettier, I have negative 10 over x to the third plus 4. Okay. So those are some tools that you now can add to your toolbox. You now have the power rule, you have the constant multiple rule, the derivative of a constant is 0, and you have sum and difference rules. Tomorrow we're going to learn about products and quotients. Actually, I think tomorrow is just products, and things get a little more challenging. Thank you.